Hello everyone, this is our session 7 on differentiation. We finished with exercise 1.1, question 1, 2 and 3. Okay, we're moving on to question 4 now. So let us begin. Yes, so the question 4 reads, this is our table that they have given us. Now we have to find out, the first question is, if r of x is equal to, so if r of x is equal to f of g of x, find r dash of 2. Okay, so what we'll do is we'll take the function r of x and we'll try to find out its derivative first, because they want r dash of 2, that means they want a derivative value. So r dash of x is equal to f dash of g of x, right, multiplied by g dash of x. Now what is the x value that they want? It is 2. So instead of r dash of x, now everywhere wherever we have x, we are going to put 2. So r dash of 2 is equal to f dash of g of 2. So f dash of bracket g of 2, right, multiplied by g dash of 2. Now we'll substitute the values. What is g of 2? G of 2 is 6. How do we find that out? Simple. G of x, right? So g of x value is 2, answer is 6. Okay. So g of 2, so f dash of g of 2 is 6 into, what is g dash of 2? So g dash of x, again g dash of 2 will be 4, right? So into 4. Again, what is f dash of 6 now? So f dash of 6, so that will be f dash of 6, which will be minus 4. So we put in the value as minus 4 over here, multiplied by 4. So what is the answer for r dash of 2? It is minus 16. I'll just solve one more of this type so that you know how to do this question. Okay, second one. Second one says if capital Rx is equal to, so function Rx is equal to g of 3 plus f of x, right? Find r dash of 4. Again, we have to find a derivative value. So find r dash of 4. So first we take down the function r of x. Okay. And we'll find out its derivative. So r dash of x is equal to g dash of 3 plus f of x, right, multiplied by f dash of x. Okay, so we'll write now what do we find? R dash of 4. So instead of x, everywhere we'll put r dash of 4 now. So g dash of 3 plus f of 4 multiplied by f dash of 4. Okay, let us find out what is f of 4 first. What is f of 4 from the table? So f of x, this is f of x. And what is f of x when x is 4? The answer is 3. So we'll put 3 over there. So this will be g dash of 3 plus 3 multiplied by, what is f dash of 4? Derivative of f dash of 4 will be, f dash of 4 will be 5. So we'll put in 5 here, right? So we have g dash of 6 multiplied by 5. What is g dash of 6 now? From the table again. So g dash of 6, this is g dash x and value 6. So g dash of 6 will be 7. Okay, so we'll put in 7 over there. So we have 7 multiplied by 5. Answer is 35. Okay, so it's pretty simple, this question. Just substitute, find out the derivative and directly substitute the values from the table. Okay, we'll move on to question 5 now. What is question 5? If dash of 3 is equal to minus 1, it's something similar only, but not in a tabular form. If dash of 3 is equal to minus 1, g dash of 2 is given to you. That is 5, and g of 2 is given to you. That is 3. We have a function y is equal to f of g of x. What do they have to find? And find, they said then find dy by dx, right, when x is equal to 2. To find out this value, dy by dx means find out f dash, basically a derivative of y. So differentiating y with respect to x, dy by dx is equal to f dash of g of x multiplied by g dash of x. Okay, so let's write down now, instead of x, we are going to put x equal to 2. So dy by dx, right, when x is equal to 2 is equal to f dash of g of 2 into g dash of 2. Right, so do we have g of 2 given to us? Yes, it's 3. G dash of 2 is 5. So let us the values. So we have dy by dx at x equal to 2 is equal to f dash of 3 into, what is g dash of 2? It is 5. G of 2 is 3, right. What is f dash of 3? They have given to us as minus 1. So minus 1 multiplied by 5. Answer is minus 5 for dy by dx at x equal to 2. Right. So this was pretty simple. Directly substitute the values they have given. Question 6. If h of x is equal to under root of 4 of f of x plus 3 of g of x, find f1, g1, sorry, not find, they've given us values also. f1 is equal to 4, g1 is equal to 3, f dash 1 is 3, and g dash 1 is 4. Find h dash of 1. Right, that means you have to find basically h dash of x first and then substitute x equal to 1. Simple. So let's just, I'll do the derivative part of it. So h dash of x will be equal to 1 upon 2 root of 4 f of x plus 3 g of x, right, multiplied by derivative of 4 f of x will be 4 f dash of x plus 3 g dash of x, right? This is your derivative. So let's substitute h dash of 1 now, which will be 1 upon 2 root of 4 into f of 1 plus 3 into g of 1 multiplied by 4 into f dash of 1 plus 3 into g dash of 1. Substitute the values and get the answer. Okay, that's pretty simple. Let's move on to the next question. Question 7 says find x coordinates of all points in the curve y equal to, or find all the points of x coordinates for the curve y equal to sine 2x minus 2 sine x. Okay, so you have to find all the points on the curve or x coordinates of the curve y equal to. Now when you have to do such a thing, you have to find out the derivative of y, because dy by dx will give you the slope of that curve. It will give you all the x coordinates of that curve. Okay, so we write dy by dx is equal to sine 2x will be cos 2x, right, multiplied by 2, minus 2 sin x will be 2 cos x. Okay, now okay, there's one condition also that they have given you, that dy by dx is equal to 0. If dy by dx for this sum is equal, this curve is equal to 0, that is slope of this curve is 0, then find all the x coordinates. So what we'll do is take 2 common. We have cos 2x minus cos x. Okay, cos 2x can be written as 2 cos square x minus 1 minus cos x. Okay, so we have 4 cos square x minus 2 cos x. So we can arrange this in a quadratic form. So we'll have 4 cos square x minus 2 cos x minus 2. Now they've given us dy by dx as 0. So we'll write 4 cos square x minus 2 cos x minus 2 equal to 0. Taking 2 common, 2 cos square x minus cos x minus 1 equal to 0. Now we'll find the factors for this one. So we'll get either 2 cannot be equal to 0. So we'll just have 2 cos square x minus cos x minus 1 equal to 0. Okay. So what are the factors? Factors can be written as 2 cos square x minus 2 cos x plus cos x minus 1 equal to 0. So we have 2 cos x common, cos x sin mistake, cos x minus 1 plus 1 common, cos x minus 1 equal to 0. So the two factors are 2 cos x plus 1 and cos x minus 1 equal to 0. We equate them to 0 and see what factors we get. So we get cos x equal to minus half, or cos x is equal to 1. Okay, when is cos x equal to minus half? So that is cos of pi minus theta gives me minus cos theta, right? So cos of pi minus pi by 3 equal to minus cos pi by 3. What is cos pi by 3? Cos 60, that is minus half over here. And cos pi minus pi by 3 will be cos 2 pi by 3. Right? So, what are the values of x that we are getting? 2 pi by 3. And when is cos x equal to 0? That is cos of pi by 2. Sorry. sorry, cos of, not pi by 2, cos of 0 is equal to 1, no? Yes, sorry, cos of 0 is equal to 1, so therefore we have x equal to 0. Also, cos of 2 pi will also be equal to 1 and it will lie in the same range. So x can take the values 2 pi by 3, it can take the value 0 and it can take the value 2 pi. All these will lie in the range 0 less than equal to x less than equal to 2 pi. So these are the possible values of x that we get: 2 pi by 3, 0 and 2 pi. Okay, these are the values of x on the curve. This is question 7. The question 8 is kind of a fill in the blank type of question. They have given you a hint basket and you choose the answers from the hint basket. So that is very simple. Okay, let us move on to the next topic. Okay, so here we are going to do the geometrical meaning of derivatives. What we can observe here is that there is a curve f of x, okay? On the right hand side, there's a diagram. Now at x equal to a, now where is x equal to a? On the x-axis over here, at x equal to a, okay? What will be the coordinates of point P? It will be a comma f of a because the curve name is f of x. So we say a comma f of a. Let Q be another point in the curve, a little to the right of P, okay, that is a plus h. So how much difference are we taking from a? We're taking a small difference h. Okay, on the right side it will be a plus h, x coordinate, and y coordinate f of a plus h. Similarly, we are taking another point r, that is a minus h and f of a minus h. Okay, now we can calculate the slope of the secant line PQ. How do you calculate slope? It's y2 minus y1 upon x2 minus x1, right? So we are taking the points P, a comma f a, and q, a plus h comma f of a plus h. Okay, slope of secant PQ is given by f of a plus h minus f of a, that is y2 minus y1, divided by x2, that is a plus h minus a. So we cancel out a. What are we left with? F of a plus h minus f of a upon h. Suppose we make now, what does it say? Suppose we make h smaller and smaller, then what will happen? A plus h will approach a as h is getting closer to 0, right? So if that difference h that we are taken, if we make it smaller and smaller, it will approach a. What does that mean? Point Q will come down lower and lower and should meet point P. That is, they should become one point, or they should become one single line, okay, cutting the curve at only one point. Okay, now suppose we make it smaller, so Q will approach P, right? That is H tending to 0. The secant converges to the tangent at P. What happens? It becomes a tangent at P. So now if limit Q is tending to P, that is Q is coming closer to P, then slope of the secant PQ is equal to limit H is tending to 0. We are applying limits on both the sides. F of a plus h minus f of a upon h, which is equal to f dash of a. This is the basic function of derivatives which we had started with. So what is f dash of a given by? Limit that small difference h should tend to 0, f of a plus h minus f of a upon h. Then we get f dash of a. So what have we proved over here? So we get slope of a tangent at P, which is f dash of a, if the limits exist. So if the limits exist, then we can say that this point Q will merge with point P and secant PQ will turn into tangent at P, and the derivative, that is f dash of A, is the slope of that tangent at P. Thus, the derivative of a function y equal to f of x at any point px1, y1 is the slope of the tangent at that point on the curve. If we consider the point a minus h to the left of a, h is greater than 0, then with r equal to a minus h, f of a minus h, we will find the slope of pr, which will also converge to the slope of tangent at P. similar kind of derivative we can take for the left hand side also, and we'll see that R also tends towards P, okay, and Q also tends towards P. That means if I take the derivative of this function, okay, y equal to x square plus 3x plus 2, then slope of the tangent at 2 comma 3 is given by derivative of that function dy by dx. So at any point of any slope, if I have to find its slope, how do we find it? We take the derivative of the function. So any tangent slope can be found out by finding the derivative of the curve. Okay, what is derivative? Dy by dx of the curve. Okay, our next topic will be inverse functions. Okay, so inverse derivatives. What do we understand by this? We've done inverse trigonometric functions. There are normal functions also which can be written in inverse forms. Okay, so what does that mean? Let us take an example as if we have f of x equal to 2x minus 2. Okay, I'll call this as a function y. Y is equal to 2x minus 2. Okay, so normally we do dy by dx, right? Differentiate with respect to x, so we get 2. Now, I'll write the inverse of this function. What is the inverse of this function? We will express x in terms of y. So that will be y plus 2 upon 2 is equal to x. This is called as inverse function of y. So if f of x is equal to 2x minus 2, right, then f inverse of x is equal to what? This function over here. Okay, so I'll call this function as g of x. Instead of writing f inverse of x, I'll call this as g of x. So g of x is equal to y plus 2 upon 2. But since I've written g of x, so instead of y, I'll put x over there. Okay, so it's a inverse function only with the same letter x plus 2 upon 2. Okay, now let us take g dash of x. So g dash of x will be what? It will be 1 upon 2, right? What is this? This is the inverse function of our f of x, right? So let us compare the two derivatives that we have. Or even one more simpler form we can write over here, dx by dy. That is differentiating this x, this expression over here, x equal to y plus 2 upon 2 with respect to y. So I'm going to get 1 upon 2. So now let us look at these two values, dy by dx, which is the derivative of f of x, I'm getting 2, and dx by dy, which is the derivative of the inverse function, I'm getting half. So therefore we can write that derivative of inverse function, that is f inverse of y, okay, is equal to 1 upon derivative of the function itself, dy by dx. Okay, also can be written as d by dy of f inverse of y, okay, is equal to 1 upon f dash of x. dy by dx is what? It is f dash of x, right? F inverse of y can also be written as g of x. It can be written as dx by dy. So simplest form to remember inverse function is dx by dy. That is differentiating x with respect to y is equal to 1 upon dy by dx. This is all that we have to remember while doing inverse functions. Okay, so we'll find the normal dy by dx, take the reciprocal, that is the answer for dx by dy. That is the answer for the inverse function. Okay, so only one thing to remember in inverse functions, it's the reciprocal of the given function if the inverse of that function exists. Very important. Okay, in the next session we will do the exercise on inverse functions. If you have any doubts in as to the explanation of inverse functions or interpretation of the tangent, do write to me. I'll explain it again. Okay. Thank you very much.